All right, you can see that we're starting section 7.2, the first day. We're going back to doing antidifferentiations, which is just another way of saying we're doing integrals. We're going to get a little more complicated, of course, and we're going to have to use a little substitution eventually. First of all, we've got to do a little discussion of what we mean by an indefinite integral. We've actually already talked about this, but let's revisit it. Basically, it says if capital F is any function such that if you take the derivative of that capital F of x, you will get small letter f. Then if you go and reverse and take the integral of that small letter f, you will get its antiderivative, capital letter f of x, plus some constant c. So an indefinite integral basically is a family of functions that differ by a constant c. Like some constant, we call it c. And that family of functions is the antiderivative. All right, well, let's go ahead and do some indefinite integrals. We're going to start with some easy ones. Some of them, and hopefully most of the time, we can just look at the problem and think kind of in reverse. You know, what do I take the derivative of to get 2e to the x? Well, we know that. It would just be 2e to the x. And then what do I take the derivative of to get secant times tangent? Well, that would just be secant of x minus, and then that square root of x, that's the same as raising it to the 1/2 power. So my antiderivative now, I have to go up with my exponents, so I will end up with x raised to the 3/2. But don't forget, divided by 3/2, which would be the same as multiplying by 2/3. And because this is an indefinite integral, we have no bounds on it. We don't have an upper and lower bound. It's indefinite. We've got to have that c on the end. Now, we can always go back and check to see if this is the case. So let's take a look. If this was our capital F of x function, then if we go ahead and we take the derivative of it, well, the derivative of 2e to the x will be 2e to the x. The derivative of secant will be secant of x times tangent of x minus the derivative of the next part. Bring the 3/2 down in front. We'll cancel with the 2/3. I'll be left with x. Go down with my exponent 1/2. The derivative of the c is 0. Well, now I'm right back to where I started from. So I can always go and kind of check these indefinite integrals. Okay, here's another one. We've done a problem like this before. So I think, well, what is what do I take the derivative of to get cosine? Oh, it must be sine. So it'll be sine of 4x. Don't forget we have to divide by 4 plus c. So if I think in reverse, capital F of x, my indefinite integral, is the sine of 4x over 4 plus c. Well, what would be my derivative of that? Well, the derivative of sine is cosine, so I would get the cosine of 4x all over 4, but oh, I've got to do the chain rule. Take the derivative of the 4x, so times it by 4. The derivative of c is 0. Well, my 4's cancel out, and I'm right back to where I started from. Okay, well, now we're going to get a little bit more complicated, because if I look at this next problem, I've got sine of x times e raised to the cosine of x. I can't just figure this out. So I'm going to have to use a little substitution. And so I always look to see what is the most complicated part. And so what I think the most complicated part is the fact that we've got e raised to the cosine of x. So I'm going to try to start with, sometimes it's a little trial and error here, but I'm going to let u equal that complicated part, that cosine of x. So then I'm going to say, okay, well, the derivative of u with respect to x is equal to a negative sine of x. And then I'm going to move my dx over, so I'll get du is equal to the negative sine of x times dx. So now I look at my problem over there, and I can see, okay, I've got the sine of x and the dx. Notice over here my substitution part, I've got the sine of x dx. The only thing that's a little bit of a problem is the negative. So I'm going to switch it around, put the negative on the side with the du equals sine of x times dx. Okay, now I can actually go ahead and make all my substitutions. I'll have the integral, and in place of the sine of x dx, I'll have to have the negative du. Okay, and then, so the sine of x and the dx are out of there, and then I'm just left with e raised to the u. So that whole problem, I'll get that a little closer there. That original problem now has u being substituted in there. That takes care of all our messy parts. I can take the integral of e to the u. If I go ahead and do that, I will just be left with negative e to the u. Don't forget the plus c. And then I can go ahead and substitute back in, and this will just become negative e raised to the cosine of x. Don't forget the plus c. Okay, so that is what my capital F of x is now equal to. Again, I can always kind of try it out and take the derivative. Well, the derivative of negative e to the cosine of x will be negative e to the cosine of x. Don't forget the chain rule. Derivative cosine, that'll be times negative sine of x. So my negatives cancel out, and now I'm right back to where I started from. So again, look for the messiest part. The messiest part in this case was that cosine in the exponent. That's what I'm going to let u equal. Okay, next problem here with the square root. Well, what I think is the messiest part is what's under the square root is the messy part. So I'm going to try to let u equal 5 plus 2x to the third. My derivative, du dx, will equal, well, the derivative of 5 is 0. I'll end up with 6x squared. Ah, that's a little clue there. My x squared and this little extra x squared there, I'm going to be able to take care of that. Okay, so let's rewrite here. We're going to get du equals 6x squared times dx. Can I now make my substitution? Well, let's see here. Under the square root, I will just have a u. This x squared and the dx, that's going to be taken care of with the du, except there's this extra 6 right there. Now, I think I'm going to have to put it over with the du. So 1/6 times du will equal x squared times dx. So I'm going to be able to take that x squared there, right there, and the dx, and in place of that, I will put a 1/6 and a du. So I've got all my substitutions taken care of. I can now go ahead and take the integral of this. Okay, I'm going to think of that square root of u as being raised to the 1/2 power. So go ahead and take the integral. I'll end up with 1/6 times u, now raised to the 3/2 power. Don't forget you got to divide by 3/2, which is the same as multiplying by 2/3 plus c. Let's simplify that a little bit. The 2 and the 6 will cancel out. I'll be left with just 1/9 times u raised to the 3/2 power plus c. Okay, let's go ahead and do the substitution. So we'll end up with 1/9. U is my 5 plus 2x to the third. Okay, because it's a 3 over 2 in my exponent, that's like doing a square root, and then my 5 plus 2x to the third, what's inside of there, put parentheses around it, is like raised to the third power. So the 2 in that denominator right there, that's for the square root part, and the 3 that's in the numerator is what's being raised to the power. Okay, we could simplify that a little bit more. We won't get into all that at this point, and then don't forget the plus c. Again, look for what's kind of the messy part, and that's going to be your substitution. Okay. And the last problem we're going to look at, we might want to remember here that cotangent and cosecant, you know, the derivative of something gave us cotangent times cosecant. And that was, if we started with y equals cosecant of x, the derivative of that was negative cosecant of x times cotangent of x. So we do know a little relation there. So really the messy part is the whole x squared business. So that's what I'm going to let u equal. And then I know that du dx will equal 2x. And I'm going to start to do a little substitution here and look at, okay, du would equal 2x times dx. So let's start to substitute here. Okay, I got my x and my dx. That's over here in my substitution part. I can substitute du for that, but again, there's that 2. So I'll put the 2, make it into a 1/2 on the other side, x dx. So let's see here. I can just put the 1/2, and then I'll have the du. So that took care of my x and my dx. Okay, and then I'll just have the cotangent of u times the cosecant of u. Now I can take the integral of that. The integral of that will be 1/2 just cosecant of u. I'm going to have a negative in there though, okay, plus c. And then again, I got to do my substitution, so I'll have a negative 1/2 cosecant of x squared plus c. And again, let's just check this here. Let's say that this is what capital F of x now equals. If we go back, the derivative of that would be, let's see now, the derivative of cosecant, that's, so I'll have my negative 1/2 times, the derivative of cosecant is a negative cosecant, okay, that plus goes there, cosecant of x squared times cotangent of x squared. Got to do my chain rule, so I'll have to take it times the derivative of x squared will be 2x. So then my 2 and my half are gone, and I'm left with x times the cosecant squared times cotangent squared, which basically is what we started with. Okay, now with these problems that you've got, you should be able to find, I have an answer sheet there. So as you're doing these indefinite integrals, you should be able to check your answers as you go. Okay, good luck.